This conference will now be recorded.
Hey, once again, good morning and good evening to everyone. Thank you for joining this session, being the long weekend, and happy New Year to one and all who have joined. I'm Satish from Isha Training Solutions. I have close to 15 years of IT experience covering performance testing, engineering, and development. That's a very short, quick introduction about me. Today, what we will see in next 1 hour, 20 minutes is more from the performance testing and engineering trends that we can expect in 2021. Right. So I guess that most of you who have joined this session probably most of you might be doing performance testing or probably even some kind of an engineering, and maybe some of you might be doing some functional testing or test managers. So for last 2 years, 3 years, we have been seeing the shift of uh, uh, the core from a core testing alone. From there, we might have seen some part of DevOps influence in performance testing, the cloud being taking a prime seat everywhere. You might have started working for cloud-based projects, and then you might have heard about SDET, SREs, engineering now becoming very important skill set, uh, since people are trying to consolidate a lot of position into one single position, right? No more you're going to see one person for performance testing, one person for engineering, one for doing DevOps engineering, right? So there are going to be consolidation of role as we move along, and as part of that, what we will see today is what is that we can expect in the upcoming years. This is going to be a slow journey, right? I mean, what are we going to talk about today? It's not going to happen next 1 month or 2 months. It might take its own time, but already this shift is started, and it is going to evolve as we move along. Okay, so quickly we'll move on to the today's session. Okay. So we, most of us in the call, as I said, I think I expect most of the people would be performance tester with varied experience. Some might be performance managers or test managers, or few might be doing some engineering, right? So pretty much we have been doing this non-functional requirements scripting using JMeter, load runner, and then regular our performance test execution in terms of load or stress or endurance, and we'll be doing the analysis and then providing the reporting. That is the typical role of a performance tester, right? And in a few projects, few organization, few of you might be just doing the scripting and execution. Somebody might be doing the requirement and then analysis. Few might be involved in doing the end-to-end performance testing, right? From the requirements till reporting, you would have got an opportunity to do the entire thing, right? So that is what a pretty much a role of a performance tester, right? Now, but as we move along, right, now in already we are seeing certain things changing with respect to performance testing, or even with entire testing industry itself. We have been seeing a lot of things moving from traditional now with current DevOps and cloud being taking the center stage for overall IT industry itself. The influence of cloud and DevOps is also made a very positive impact on the way we do the testing also, right? So with that, what is going to change? What we can expect, right? If I'm now a performance tester, is it good enough for me to do a same thing what I have been doing till now, or do I need to pick up new skills? What is the industry is expecting, right? That is what we are going to see today. So there are five broader categories, five different things we might encounter depending upon the project you work. depending upon the customer you work, depending upon the enterprise you're going to work. Okay, so these 5 things are going to be here, which I'm going to talk about. On top of this, your core skill set of performance testing and engineering is going to stay same. I'll explain that why I say that. There is going to be one core part that is pretty much going to be there, and it has to be there, which is going to be your performance testing and engineering. Okay, which you might be already doing it. If Probably a lot of performance testing, and probably you might be doing a little bit of engineering today, right? That is going to be same. Performance testing and engineering is going to be core part. Along with that, what you might start working depending upon your project, and you might need to pick up some skill set for these aspect as you move along, right? So 5 areas that you might encounter, or you might be start working on, would be: one is the cloud, right? When I say cloud, it could be you might be testing the cloud based application. That could be one. Or you might be using the cloud itself for our own performance testing environments. I'll talk about that, right? So the cloud is going to be a big part, and you might, if you've not been started working on that, very soon, for sure, in this year, you will be started working on the cloud projects. Okay. Number two is DevOps, right? Mostly, I would say 80% of the time, DevOps is considered for continuous deployments and your functional testing, functional regression. But when it comes to performance, it's very minimal. But that is already changing. That is going to change very soon. But is it going to impact the role of performance tester? Is the automation is going to impact the performance testing? Maybe not. We will see how it is. Okay. Third is going to be site reliability engineering. The site reliability engineering, or SRE, is a separate role, but again, now it is getting merged into performance testing. A performance tester should also be able to pick up skill that is going to help them play a role of an SRE. We'll see about it. Okay. And the fourth and fifth thing is something interesting. First three things, whatever we have, the cloud, DevOps, the site reliability, is going to be, I would say, within the scope of performance itself. We're not going to expand out of that. Right? Whatever we are going to see within the cloud, within the DevOps, within the site reliability, it's more and more just about performance. But other two things are going to be little bit out of performance, which is nothing but your full stack testing, and then SDET. So full stack testing is nothing but you might be asked to just not do performance testing. One single person should be able to do functional, manual, automation, security, or performance, depending upon the goal of each of the individual enterprise teams. The agile team, they might not be having a cushion of having 3 testers, 4 testers. Expected skill set would be one person should be knowing the end-to-end testing, full stack QA. SDET is something even more than this, right? A person should be able to do testing and also development. He should be able to work with developer. He should be able to go and fix a problem, just not provide observations, just not provide recommendation. Go fix it and work along with the developers, right? So both testing and development has to be done by the same person, right? So these are the 5 things you might encounter, or you might be in any of the projects, or in any of the your other applications, wherever you're going to work on. These things might be coming to you, and you might need to upskill yourself to meet the demands of the market. And again, I wanted to stress one thing very, very clearly. These things are going to evolve. Things are going to change. There are going to be some primary drivers in the market. The people like Microsoft, Google, Netflix, all these people are very, very advanced in technology, and they come up with all these different terminologies, different way of doing things differently, right? SDET, SRE, all these things, if you see, it might have come from all these top tier technology companies, be it Apple or Microsoft or Google or Netflix. They keep these things, they keep evolve these things every year, and these things are going to keep changing. After 2 years, you might see a different terminology, different way of doing things, right? Which means, while we wanted to make sure we know what is happening in the market, our core things are going to be performance testing and engineering, which you should be master it and pick up any of these skill set that is going to be important as you start working on these projects. Okay, so let's just go one by one. Okay, first we look into the site reliability. Okay, the way we'll do it is I'll spend some time on the site reliability, and then we'll spend some time on this full stack QA and test, and then we'll move to the DevOps, and then we will move to the cloud. Okay, and then we'll see how are we going to what is that required for us to strengthen our knowledge, right? Because all these things are individual areas. We cannot just go and master it right away. One, we need to know what is happening in the market. That is the ground reality we should understand, and then uh, focus on what is that something it is required for you to move from your regular activity. Today, if you're just doing scripting and execution, you should be able to go to the next level. If you're doing end-to-end performance testing, maybe you should pick up the performance engineering. If you're already doing performance engineering, probably you should try to expand your knowledge in being an SDET or SRE, right? You should try to evaluate yourself. Where are you today? And in 2021, these are the expectation in the market. Probably you should try to expand slowly to improve your knowledge. Okay, so SRE, right? Site reliability engineering. It's more about ensuring your application is your website is reliable, right? It is a little bit of expansion to your performance testing. So we have been doing this load testing, stress testing, endurance testing to make sure your application doesn't crash, application doesn't go down, your performance response time SLAs are met. All these things are going to be part of our regular performance testing. And if you're going to expand that little bit, right, that is what it is going to be: site reliability engineering, which is going to cover certain things from a production perspective, right? One is going to be more about your end user experience, right? Because your end users are going to use the website, and how is their experience, how is their application is going to be reliable, right? So that is going to be part of your end user experience. Your users launching your app either through your native apps in your mobile apps or using Chrome or Firefox. What is the end user experience in terms of your response time? You need to ensure that not only your server side response time is evaluated as part of your JMeter testing or load runner testing. You also should be able to ensure that your end user response time, your browser level response time, at a native level, native apps response time, all these things are important when it comes to end user experience. So that is going to be one of the additional activity or additional skill set or additional approach that is going to be part of your site reliability engineering. And then second, when it comes to reliability, it is more about making sure your application is running 24/7 without any interruption. Sorry to probably, if you have any questions or if you want any suggestions, any comments, start putting it in the chat box. Probably we'll spend some time at the end of the session and I can answer your questions. Okay, so please post your question in the in the chat. Okay, so when it comes to synthetic monitoring, it's very important to make sure to evaluate your application in production continuously 24/7 to make sure your application is available. If your application is performing at a expected response time, right? It is more like health check in production, right? Before even your actual user is going to complain saying application is slow or application is not available, we will be running your JMeter script or a Selenium script continuously every 15 minutes with a single user. We're not going to run any load test here because it is in production. Production is already going to have a load. Okay, we are going to run a synthetic scripts, which could be a JMeter script, which could be a Selenium script, which will be running every 15 minutes once in production, which will check whether the application is available or not, whether you're getting 200 response code. If you're getting a 500 response code or 404 response code, or if your response time is more than 5 seconds or 10 seconds, alerts has to be sent to your development team or your support team. Okay, so synthetic monitoring is going to be creating the synthetic scripts, configuring your synthetic scripts, and then setting a proper rules and configurations are going to be part of your site reliability. Third is more from a real user monitoring. Again, that is going to be part of this SRE role, where the feedback from your real browsers, right? The users might be logging in from US or UK. They might be using mobile or browser, Chrome browsers from their desktop. They might be using a slow connection or 4G or Wi-Fi. So the lot of data will be coming from your browser cookies to your real user monitoring tools, right? So analyzing those data is also going to be important to understand who is your end users. What is their real experience when they launch your application from their browser? That is also going to be part of um, your site reliability engineer. And then a regular server and app monitoring using Dynatrace or AppDynamics, right? So continuously monitoring your application in production is going to be important, so that you as a performance tester, mostly you'll be working on a pre-production environment or testing environment, right? But what happens in production is important when it comes to site reliability. You should just not do load testing, endurance testing, and then say SLA is met or not. In addition to that, you should also participate in production monitoring, production evaluation. That is where all these things comes: end user experience, synthetic monitoring, your real user monitoring, your production monitoring using Dynatrace or AppDynamics, and then also it comes your resiliency, right? Resiliency, again, it is going to be one of the important aspect of site reliability engineering, right? We might be testing our application for say 1,000 user, 2,000 user, and then running an endurance test for 12 hours. All this is fine, but when chaos is going to happen in production, right? Say for example, one of the server is going to go down all of a sudden, or when your odd disk is going to get crashed, or if your network is going to go down. Under this extreme conditions, unexpected conditions, chaos condition, how is your application is going to behave? Is your application designed to handle this chaos condition? Um, that is what it is going to be part of your resiliency. Whatever you tested, whatever you make sure performance testing is done properly, there are going to be problems, there are going to be outages, there are going to be crashes. It is 100% not possible to avoid these chaos, right? But your application has to be resilient, right? When something happens wrong, your application should be able to recover fast. Your end user should not be able to get impacted for extended period. So when that kind of a chaos happens, how your application is going to handle it, how it is going to recover from that chaos condition, that is what it is going to be part of your resiliency, right? Probably if you might have been a follower of cricket, right? You might have heard people talking about resiliency. Probably the last test match, if you would have watched, people are talking about India is not resilient, right? They were been all out for 36. People are talking about Indian batting lineup is not resilient. When your number 2, number 3, number 4 wickets fell down, when everybody failed, right? um, that is more about resilient. When there is going to be chaos, when 5 of your batsmen, 6 of your batsmen is going to get out, how is your other people are going to recover from that, right? That is what it is going to be all about, resilient. When it comes to software and it comes to application, when that is going to be a chaos cannot be avoided. It can be limited. We are doing a lot of testing engineering to profile it, to make sure your application is going to be doing well. But in some stage, there are going to be network outages, there are going to be hardware crashes, there are going to be network problem, there are going to be server getting crashed. So resiliency is going to be more about creating those chaos condition in performance environment, and then testing it for those conditions, see how application is going to recover during that condition, how is their performance is going to get impacted, and how is their end user is going to get impacted. That is going to be part of your resiliency, right? So all these things are going to be part of your site reliability engineering. Okay, so more and more now, if you see the job descriptions of companies, they are saying I need a SRE. But if you see the job description in SRE, they will say people has to know JMeter, people has to know load runner, they have to do execution, they have to do all these resiliency. So it is kind of, people are trying to squeeze in all these activities, all these responsibility into one single role, right? So you might see a role called SRE, but inside that, if you see, it is going to be completely performance testing or engineering. In addition to that, they might have mentioned about these resiliency, and then synthetic monitoring, end user experience. So you should be able to pick up the skill set if you wanted to be probably suitable for this kind of a role, right? But this is something definitely you can expect to happen, to evolve as we move along the 2021 or 22. Okay. Next two things are going to be little interesting. It is not going to be mandatory to be a SDET or to be a uh, uh, full stack QA engineer, right? Full stack QA engineer and SDET are more prominent now because of DevOps and Agile. You have a pod team, right? Small teams, pod teams, comprising of just 3 or 4 people working together, right? Those 3 4 people could be, one could be a developer, one could be a full stack QA engineer, a 2 developer on full stack QA engineers, or people could be an SDET engineers, right? So in the agile world, where people are where multi-skilled people are going to be the expectation, there are going to be small teams. Only small teams are going to be there, and each small teams are going to focus on particular modules, and those 3 4 people have to take care of doing testing and development completely. So in few places you might see one person will do development testing together, or in one team you will see one person doing every testing, all the testing, manual testing, functional testing, performance testing. Which means in your organization, or probably in your projects, or your customer place, you might foresee these positions, right? You might not see performance testing alone required in some places. So which means you should try to upskill yourself in automation testing, your Selenium based automation, manual testing, security testing, right? It is not going to be that easy. It is going to be a journey. It depends upon where are you today in your organization, in your company. What is that their journey of this digital expansion? Depending upon that, you can probably try to learn automation testing tool, Selenium, or QTP, or whatever that is required in that place. You can probably pick it up so that you can do both automation and performance testing together. If you're not going to do it, probably then automation tester is going to do the vice versa. He is going to learn performance testing, and he is going to do automation plus performance testing. So it is like, who is going to win the battle, who is going to take up this role. Automation tester can learn performance testing and then can take care of that project, or performance tester can learn automation testing and can do both the things. So full stack QA is picking up in a lot of places, very specifically in the places where the agile based, DevOps based projects are getting executed, where they cannot have a cushion of having too many peoples, right? They have a limited budget. They cannot have 3 5 4 people, 5 people for specific skill set. So that is where this full stack QA is going to be coming into picture, and it is very important for you to know this trend. And if at all possible, you can upskill yourself to a functional tester, and very specifically an automation tester. Similarly, for SDET, maybe it might be over ask or overkill, because it's not going to be that easy to pick up the development knowledge, right? It all depends upon if whether you already have a programming language skill set or not, or what kind of experience you already have. Because you being a performance tester, you need to probably then you have to pick up the performance engineering. From there, you should be starting to provide recommendations, and then you should be able to go and fix those, and then deploy it, and then do testing. It's going to be kind of a loop. You do testing, you do engineering, you provide recommendations, you apply the recommendations, and then go and test it, see whether it is improved or not, right? So you should not be doing a black box testing anymore. If you wanted to probably move towards an again moving towards SDET, you're not going to do a complete development, right? May not be possible at all, but you should be starting to do a more of a white box testing, engineering. If you're just doing a testing, you should start doing engineering, and then provide recommendation, and then go and fix, provide those, apply those fixes, deploy it, then test it and see if it is fixed, and then take it to the developer. That is what you're going to do it. So you that is going to be the first part of the SDET. And then probably as you pick up any of the programming knowledge language like Java or Python or JavaScript, then you can efficiently do those small enhancement also by yourself, right? So SDET is also going to be something important. It's going to get evolved, but we are not going to completely turn into a developer. That is not required, and that is not also going to work out, right? Again, with that, a lot of quality problem is going to come. I mean, because when a developer is going to do a testing, you might miss out a lot of scenarios when it comes to testing. So there are a lot of failure model also with with SDET. So we're not going to see completely a tester is going to do a development, but as I said, expectation from an SDET in a project would be you should be doing an engineering, you should be providing a fixes, you will go and change the code, and then deploy it, and then test it, and then provide those inputs to the developer. That is what it is going to happen as part of the your SDET. Okay, so this SDET and full scale or full stack tester is going to be out of your comfort zone. From performance testing, you should be able to expand your knowledge either towards the automation skill set with Selenium or QTP for you to be an full stack QA tester, or to be an SDET, you should start yourself investing your time on engineering, profiling, providing fixes, and then learning the any of your programming language. Okay. Next two things are going to be within your boundary, right? I was talking about cloud and DevOps in the top, right? We have seen the SRE. Again, SRE is going to be within our scope, within our boundary, within our, I would say, within our comfort zone. Just that we are going to learn some new things, but still that is all part of the performance only. Only the SDET and the your full stack testing is going to be a little bit different. Okay. So the cloud and DevOps is going to be, I would say, the way the technology has improved. Again, performance testing and engineering is not going to change, but we need to probably modify our approach. Probably we should try to put a different strategy towards the way we are going to do the performance testing and engineering. When it comes to DevOps, when it comes to cloud, that is what it is going to change. We're not going to change the way we are going to do a load testing or endurance testing. We're not going to change the way we are going to do the engineering, but how it is going to be done, it will be a little different. Say DevOps, right? So far, in most of the places, in 80% of the projects, DevOps is more about continuous deployments, and then smoke testing, functional automation. That is what it is going. It was happening as part of the DevOps lifecycle. The remaining 20%, your people like Microsoft or Google or Netflix, those people have been doing they are in a complete different zone. right? Um, the way the architecture they have in their application allows them to do complete end-to-end automation of deployments, and then functional testing, performance testing, deploying in production, right? Everything happens seamlessly, completely automated way. Every 1 hour they have production deployments. They have couple of deployments in production in daily. They have hourly deployments, they have daily deployments, completely automated life cycle. That is because they have a very good architecture, microservice based architecture, which allows them to do this testing in completely automated way. You don't need a person to do scripting, you don't need a person to do execution. Since it's a microservices, everything is getting automated. Scripting automatically, the scripts getting generated, your load testing is done automatically. The results comes out, they do comparison with the SLA, and then everything is okay. It gets deployed in the production. But that is happening only in the 5 to 10% of the organization, maybe in Microsoft, in the Google or Netflix, maybe in few other organizations. But rest of the areas, rest of the enterprise, rest of the organization, it is not going to be that easy. uh, they have different architecture, they have different way of technologies, which doesn't allow them to do the complete automated testing in the DevOps pipeline, right? So what is going to happen, right? What is going to happen shortly is certain things is going to be part of the your pipeline in DevOps pipeline. When a deployment is going to happen, your performance testing will also happen automatically, right? You don't need a person to do the your regression performance. Say for example, if you have REST APIs, if you have web services, if you have landing pages, URLs, right? For those things, you would not need, there won't be any impact to your existing JMeter scripts. There won't be any impact to your load runner scripts, right? You might have already created a script for that, which is going to be running automatically in the DevOps pipeline. There won't be any impact to the scripting because it's just an landing pages, landing URLs, your REST APIs, web services, microservices, all are going to be simple get calls, post calls. Okay, which means those can be run automatically for every build within a sprint, or for any build deployments, every major builds. This regression testing can be done continuously, saying my build is passed or failed depending upon the response time SLAs, depending upon the your previous uh, response times, right? These things can be automated. But the code that is getting developed within the sprint, right, that is not going to be evaluated immediately for performance testing because you will not have any scripts, right? If you have three functionality already available, for those three things you might have scripts. But within the script, if a functionality 4 and 5 is getting developed, that will not go through performance testing. Rather, performance engineering will happen within the sprint. You as a performance tester or engineer will work with along with the developer to do the early performance testing, server-side profiling, client-side profiling. All these things will be happening manually by a performance engineer. So there are three things. One is going to be your regression performance, which is going to be automated in the pipeline. And second thing is going to be performance engineering is going to happen within your sprint for the product, for the features that are getting developed within the sprint. And then end of the sprints, you're going to have a regular performance testing, completely 1x, 2x load, endurance testing, all these things going to happen before the production release. So that is something you can expect as part of the your DevOps. So it is not going to be completely automated. It is not going to, or it is not going to be other way around also, where performance is not going to be part of the DevOps. It's going to be, there is going to be a line between both the extremes. We are going to see certain things getting into pipeline, few things getting automated, and then engineering is going to be part of your sprint, in sprint activity. And then as usual, your regular performance testing is not going to get replaced. Whatever you have been doing is going to be there. On top of that, you're going to have a regression performance, which is going to get automated. You're also going to do a lot of engineering activity, which means with the DevOps, performance testing is not going to go away. In fact, we are going to get even more additional responsibility, even more additional work, because in DevOps, two things are important: speed and quality, right? The main objective of DevOps itself is to speed up your production release. Okay, so but we cannot compromise on the quality, which means speed and quality are both going to be important attribute. So which means for quality, we are going to have our regular release based testing or engineering. Sorry, in fact, the release performance is going to be there. We are going to run a full-fledged load testing, stress testing, and endurance testing. Within the sprints, you should act as a performance engineer to do the server-side profiling, engineering, JVM benchmarking, all these things. And then within the sprint, for each build deployment, you're going to have a automated performance testing. Okay, so that is how the role is going to get evolved, and the responsibility is going to get increased. So the myth of DevOps is or performance testing will go off, it will get replaced. That is not the true. It is going to give us more and more work, more and more job. But only important thing is we should be able to fit into that role. We should be able to do this engineering. We should be able to do code profiling. We should be able to do the JVM benchmarking, client-side profiling. All these things we should be able to upskill ourselves so that we would be able to part of the in-sprint activity. Otherwise, that's going to be difficult. In DevOps world, you should be able to do all these activity. On top of that, you will be doing your regular scripting and execution. Okay. Similarly, when it comes to cloud, right? So when it comes to cloud, again, there are a lot of myth, right? I would say there are two things you need to take care of cloud. One, how are we going to test the application which are going to be hosted in cloud? Second is, how are we going to make the use of cloud, power of cloud, to improve the efficiency of our testing itself, our testing tool, our testing load generators, testing environment, right? So two things we have to classify it, how it is going to, how the cloud is going to influence us. Okay, first thing is with the cloud, there is a myth saying, or not even a myth, a lot of places project managers who sponsor the testing team, right, they will say, why do you need performance testing? Because cloud is going to ensure the scalability or the performance, right? Why do we need performance testing? I'm going to get 10 machines, 20 machines, and the performance is going to take care of the cloud, taking care of the cloud, right? So why should I invest in 2 testers or 3 testers? The problem with that is, yes, of course, the cloud provides you the infra. It is going to take care of providing the machines on the fly. If one server goes down, you're going to get the another server within 5 minutes, 10 minutes. Scalability is going to be not a problem at all, right? Because say, for example, if you want to increase your load from 1x to 2x or 3x, and if you haven't estimated those additional traffic for your company, right? In traditional world where the machines are hosted in data center, if you haven't forecasted the business growth, you might not be able to get procure machines very fast, right? It has to go through all approvals. They have to go and procure it. There's going to be a lot of operational overhead. But now with the cloud, that is taken care of. If you need emissions, you'll get it in another 30 minutes, 15 minutes, 10 minutes, right? That is how the cloud is going to help us in scaling your infrastructure. But that is the business for the cloud itself, right? Your Azure or AWS, they're going to earn millions and millions because of the need that is going to come from the application team asking for more infra, right? Which means if your application is not properly tested or properly engineered, right? What will happen? Your application is going to have response time problem. Your application is going to have memory problem, which means it is going to incur more resources. Instead of your machine, instead of your application needed just 2 missions or 3 missions, you might be using 5 missions or 6 missions. Yes, cloud is going to provide you these scalability. Yes, it's going to provide you infra so that your end user response time is not affected. Your end user is not affected, but your company or your application team might be paying 3x or 4x more than what they might be spending with the data center itself. So advantage of going to cloud is not going to be benefited in terms of cost, right? So that is what it is happening in a lot of places. There are a lot of case studies, a lot of use cases explaining this performance for cloud, why performance is important for cloud, how companies have lost money since they haven't considered performance testing or engineering, assuming that cloud will take care of it, right? Which means whenever there is going to be a question asked to you from a project manager saying, why do you need cloud? Why do you need cloud performance testing? Why do you need performance testing for the application hosted in cloud? This is going to be your topmost answer. If you're not going to invest your people in doing proper performance testing and engineering, you're going to pay more money to the cloud providers. You will not have any control over the how do you pay money to the AWS or your Azure. Okay. And one more thing is your application is not changing, right? Only the infra is going to change. The cloud is just renting out missions, right? Renting out service. It is not going to do anything with your application itself. You're going to have a same application, same Java application or .NET application or whatever Python application, which is something you already have it in data center. You're going to migrate it to your cloud, which means if there are going to be a problem with the application, performance problem of the application, it is still going to be there. So your testing and engineering is going to be pretty much same, not going to change, and it is lot more relevant even if you're going to have your apps hosted in the your cloud. Okay. That is something we should be aware of it. You might be starting working in your cloud-based project if it's not already. And when it comes to cloud performance testing, if somebody is going to tell you performance testing is not required, that's a risk they are going to take it. You as a performance consultant or a performance engineer, you should highlight saying that performance testing is mandatory, performance engineering is mandatory, profiling optimization is important, so that you can reduce the cost of your infra in the cloud. That is number one. Number two, what is going to change in terms of approach, performance testing approach? What is going to change? Your regular load testing, stress, endurance, everything is going to be same. And engineering, server-side profiling, your memory leak analysis, your heap dumps, your thread dumps, garbage collections, your database analysis, AWS report analysis, all these things are going to be same, relevant, nothing is going to change. You might need to probably add one or more additional testing scenarios. You might be using few different tools for monitoring. That is what it is going to change predominantly. Okay, so when I say different testing scenarios, there are one important thing is going to be your scalability related scenario. So we talk about cloud is providing scalability. Cloud is going to auto scale, right? When there is going to be a demand in your usage, if there's going to be increase in traffic all of a sudden, maybe at 9 a.m. or in the weekend, there is going to be increase in traffic. With the auto scaling feature of cloud, it is going to spin up new missions on the fly. Say for example, if you're currently your production servers are running at with 2 servers, and all of a sudden at 9 a.m. there is a very much increase in the traffic, and your CPU is getting close to 70% or 80%, right? Depending upon that CPU threshold or memory threshold, your cloud provider, AWS or Azure, is going to spin up third mission, fourth mission on the fly. Okay, so during that time, what is going to happen to your performance? Is there an impact during this auto scaling? Is there is there increase in error rate? Is there increase in response time? How fast your missions are getting auto scaled within 2 minutes or 5 minutes? Because when it's going to auto scale, it is going to provide the mission, it is going to deploy the application, it is going to add it to a load balancer, and then your traffic will be routed to the third server, right? So which means during this time, it might take 1 minute, it might take 3 minutes, it might take 5 minutes, depending upon the your application war file, how big your war file is, how much time it is going to get time to deploy it, right? So you need to, as part of the auto scaling, you should include a scenario to understand your performance impact during this auto scaling situation. Okay, so that is going to be one additional scenario you might need to include it as part of your when it comes to cloud based performance testing. Okay, as you see in the diagram, whenever there is going to be a threshold reached for your traffic, whenever there is going to be an increase in CPU, you see from us one mission it has increased to two missions, and then after some time there is still more increase in traffic. Your CPU might have increased it, and it has increased to three missions. Okay, and similarly, if the traffic is going to come down, maybe after your peak period of 10 a.m., 11 a.m., if the CPU is going to come down, it will also remove the additional mission from your load balancing. So which means it is going to auto scale up. Also, it is going to auto scale down. So that will be taken care by your configuration in the environment. But as a performance tester or engineer, it is our responsibility to mimic this in the pre-production environment, to know what is the impact when the server is going to get scaled up, and during that scaling period, what is the error rate, what is your CPU, what is your memory impact, what is your response time impact. All these things you need to evaluate. Okay, so this is something you need to understand. And apart from this, resiliency, I already talked about. Resiliency, though it is going to be same for data center based applications or cloud based application, it is more and more now talked in the cloud based scenarios. The resiliency word, for whatever reasons, it is now associated with the cloud. So which means the resiliency scenarios has to be part of your cloud based performance testing. So again, to keep it simple, whatever you're doing, testing, load testing, stress testing, endurance testing, and engineering activity, all the engineering activity, on top of that, you might be need to include this auto scaling scenario, and also the resiliency scenario. What happens when my CPU is going to suddenly increase to 0 to 90, when one server is going to get crashed, when there is going to be a network latency in one of the server, what happened to my application response time, what happened to my availability of my servers. That is going to be part of your resiliency. And to create this chaos, it is not going to be easy to create this chaos. You cannot just increase the CPU to 90%. You cannot just bring down the server. You cannot just create a network latency, right? That is not going to be possible. For that, there are going to be tools like Chaos Monkey. There are going to be tools like Gremlin kind of a tools in the market, which will create this chaos, creating a chaos of sudden increase in CPU, sudden crash of a server, sudden increase in memory, sudden network problems, network latency. All these things mimic, all these simulations are done using these tools like Chaos Monkey or Gremlin kind of a tool. While that is happening, we'll be running our regular endurance test using our load runner scripts or gmeter scripts, and we'll be monitoring our your servers, and then see what is the end user impact, how what is the error rate during that chaos. Is my application is getting same kind of a response time? There are going to be impact to the response time, there are going to be impact to the error rate, but how fast that is getting recovered during that period, of how far the response time are getting impacted. That is going to be part of our resiliency validation. Okay, So two things on top of our regular testing and engineering. That is more from the our testing strategy or engineering strategy. But using the cloud, the way we are going to use the load generators for our load testing, right? That is also going to change because so far we might be asking to give 3 load generators, 5 load generators, and people might be investing money on that. With the cloud, you can just spin off this mission whenever you require. I'm going to run a test now. I'll go and spin off those 5 missions, 10 missions, use it for my execution, and then terminate it. Right? That is going to be one of the your change that is going to you want to see with the power of cloud. You don't need a dedicated load generator anymore. Why to invest money in 10 load generator completely for 1 year? You're just going to run a test only once in a week or twice in a week. That point of time, you just spin up the machines, install JMeter, install load runner, run it, and then terminate it. So cost is going to be saved. So that is something you need to aware of. Similarly, performance environment, right? You might have seen you might not be getting completely sized environment, 100% sized environment. You will not be getting it. You may be just getting 1 server or 2 server, 20% scale environment. But now with the cloud, again same logic. Whenever you need to do a testing, spin up as many servers you required similar to production, deploy the application, run it, terminate it. Which means you will not have face a challenge of performance environment anymore, right? So these two things you should be aware of, and you should be able to talk to your developer, talk to your infra team, to get your load generators, to get your performance environment on demand, right? So that is something you should be aware of when it comes to cloud. Okay. So before going to this, again, just summing up these 5 things, right? Now we are a performance sister. Market is changing, expectations are changing. What is that we are going to pick up when it comes to skill set? Performance testing and engineering is going to be core. On top of that, you're going to see yourself working for cloud-based project where you should be aware of how are you going to do a testing for cloud-based applications, and how are you going to make use of the cloud from a load generator perspective or from an environmental perspective. And in DevOps, you should pick up the engineering skill set, because one person should be able to be part of the DevOps team doing both testing and in sprint engineering. Similarly, reliability engineering, you should be able to pick up the end user experience, synthetic monitoring, real user monitoring, additional roles. And SDET and full stack testing is going to be a little different. Either you should be able to pick up some automation skill set, or for SDET, again, engineering is going to be a important role. You should be able to move from testing, learn engineering, provide recommendation. Also, you should be able to go and pick up any of the programming skills. So, having said all these things, right? Um, um, Things are going to get evolved. As I said, all this cloud, SRE, SDET, it can be, it might be there today. Tomorrow, somebody might be totally coming up with a new concept. People like this Microsoft or Google, they might be changing these tools, technology overnight, right? And other companies just go and follow their way of doing it. So there might be a lot of changes to these containers, these Dockers, Kubernetes, your the way DevOps is happening today. All these things will either get evolved, or it might just go off all of a sudden, right? But what is not going to change? Your basics of performance testing and engineering is not going to change. Whatever is going to change, this is going to remain constant. And always you should try to strengthen your basics, right? You should be able to very strong in creating scripts, doing the non-functional requirements, executions, your bottleneck analysis, and your engineering, right? So something, if you're not probably doing engineering today, that is something you need to pick it up, because that is going to play a part in most of these areas, in the cloud, in the DevOps, in the reliability engineering, in the SDET. All these places, one common factor is going to be your testing and engineering. Testing, since I assume that all of you might be doing the testing already. engineering is something going to be common touch point in all these areas, which means that is something you should be able to expand your knowledge. So you should be able to strengthen your basics in testing and engineering, and then as per the demand, as per whatever that is required in your enterprise, in your project, in your customer place, you should be able to expand your knowledge either in automation skill set, or probably in the SRE based skill set, or probably taking up seriously on DevOps automation or your cloud performance approaches. That is how you should be able to focus yourself this year, strengthen your basics, and then expand your knowledge in the new areas. Okay. So I'll just take a pass here. I'll go through a couple of questions. Okay, and then we'll also open it up for the question and answer if somebody wanted to ask something, or even if somebody wanted to share some of your experience or your knowledge on these areas, or if you have a different opinion also, you can feel free to uh, voice out your opinion. Okay, just go probably some questions what I have it in the chat. Site reliability engineering utilizes AppDynamics, Dynatrace kind of APM tools, or few more in addition to this. So site reliability engineering, okay, we'll just go one by one, right? When I say end user experience, tools are going to be your developer tools, your Chrome developer tools, your Firefox developer tools, and then you're going to have Dynatrace, AppDynamics, of course. And these Dynatrace and AppDynamics have separate components for synthetic monitoring. They have separate components for your real user monitoring. Okay, so and again from resiliency, there are tools like Chaos Monkey, Gremlin, kind of a tools available in the market. Okay, but when it comes to synthetic monitoring, apart from AppDynamics and Dynatrace, there are a lot of other tools also picking up now. Rigor, and then there is something for Site 24/7. So there are a lot of tools picking up in the market when it comes to synthetic monitoring. Your New Relic, BlazeMeter as the API monitoring. So on real user monitoring, Google Analytics you might have seen, IBM Tea Leaf. So these are the tools when it comes to your site reliability. And of course, yes, as you mentioned, Anupam, AppDynamics and Dynatrace are going to be are widely used in terms of end user experience, synthetic monitoring, and real user monitoring. And what is the difference between synthetic monitoring and app monitoring? From Bharati. See, app monitoring is application monitoring from a server side. You're just going to look into the application side of your metrics, like your CPU, your memory, your threads, your garbage collections, your database queries, database performance, everything from a server side. From a synthetic monitoring, it is more from the production side, from an end user perspective. From a synthetic monitoring, we are not worried about whether a CPU is more or memory is more or thread is more. No, whether my response time is within 5 seconds, whether my application is available 24/7. That is what you will do it from a synthetic monitoring. From an app monitoring, it is more into technical aspect, more from your server side of your monitoring. Okay. In real time, do cloud vendors take care of cloud related resiliency, or it comes to application team and thereby to PT folks? There are different types of application, right? If it is going to be software as a service, right? If a company is going to provide a software as a service, then most of this thing will be taken care by the cloud provider or the product vendor. Okay. Or if your cloud is going to provide the infra, just the infra, right? Then there is going to be two kind of resiliency here. Cloud is going to your AWS or Azure will make sure your infra side of resiliency is taken care. If one service goes down, if one data center goes down, one region goes down, they will ensure that other missions are going to be up and running fast immediately. So one infra part of the resiliency will be ensured by your cloud provider, but how soon your application can be deployed, how soon your application can start responding. Say there is going to be a network latency in one of the downstream services, whether the upstream services are going to getting timed out, or is it going to just keep waiting for the downstream to respond. Then it's going to be a mutual responsibility of both application owner as well as from your cloud vendor, right? So to answer your question, if the application is owned by your own development team in your organization, resiliency has to be done by our performance testing team or engineering team or reliability engineering team. But if it is going to be a SaaS product, completely product provided by a product vendor like Salesforce, right? Salesforce is going to be a SaaS product where software is provided by Salesforce. Is also going to provide the cloud. In that perspective, our role of resiliency is going to be not that much. We may need to just probably make sure they have done all these things, validate their reports, validate their results, but our involvement will be less. But for other areas where we are going to take care of the application development and we are going to make the power of cloud only for the infra, then all the testing, engineering, resiliency will fall under our responsibility. Okay. And one more question on, if it's a sprint based release, based on what app code changes should be required the performance testing, app code changes should be decided to require performance testing, because sometimes development team will do the fixes in the last minute until no performance testing is needed. Okay, see, if you are a performance engineer, or if you have a proper skill set to review the changes, right? Development team, their goal is to develop it and deploy it. They will be on hurry, right? There might be very good architects who will be able to take those decisions, also saying this is not going to impact the performance because they might have just changed some part of the code or some part of the UI. They know that it is not going to impact the performance. But you as a performance engineer, you should be able to review the code changes. You should be able to review the requirement for which they have done the code changes, and you should also be able to work along with those architects and make the decision collectively. Or if you feel that no, this might have an impact, we should be able to talk to them and then convince them so that they will not deploy the code immediately. It should go through proper engineering or testing. So development team, yes, they will try to do a little bit of domination because they will be on a hurry to do a quick fixes for some production issue. But if you are a good performance engineer, you can also do the same thing. You can also say yes, testing is not required. That is also going to be our role. You cannot just go and do a testing for every changes, right? So if you know the application architecture, if you are good in engineering, you should be able to understand the requirement, and you should be able to talk to a developer for 5-10 minutes to understand what they have done the changes. You can do the code review and then say yes, testing is not required. So that decision within the sprint, whether the testing is required or not, if you have a proper engineering skill set, you should be able to do it. How does end-to-end performance testing and engineering going to work in microservice model? No, it's not going to change anything at all. It's going to be pretty much same. Probably a scripting effort will come down because scripting might also get automated because it's all going to be get calls, post calls. But otherwise, your testing is not going to change. Engineering is not going to change. Maybe your level of complexity in scripting is not going to be that much. You're not going to have a lot of correlations. You don't need to go and do recording or script maintenance. That will come down drastically. But the kind of testing scenarios, execution scenarios, analysis, profiling, your memory analysis, heap dumps, thread dumps, garbage collections, DB analysis, nothing is going to change when it comes to a microservice model. Okay. And then when application was hosted on-premise, we are performance tested and certified. Now application is migrated to cloud with same sizing as on-premise. this performance testing is still required? Yes, absolutely it is required. For all the cloud migration project, yes, performance testing is very, very much required, because uh, you're going to get a new set of infrastructure, right? And your cloud is going to be, you never know, cloud is going to be in the same location or a different location. Your end users could be in US, maybe in southern side of US, say for example Florida, right? And your now your earlier your data center could be in Florida. Now with you're moving to cloud, your Amazon might be having a cloud center in Seattle, which is western part, right, northwest, which means you're going to have additional latency. Your end user response time might be um, uh, might change. Your there might be a hybrid deployment. Your database could be in data center, your application server could be in cloud. So all these, depending upon what are the things that are going to change, you need to definitely do this regression testing. Performance regression has to be done before it is rolled out into production. It is absolutely mandatory. Okay. If it next question is, if it's cloud based environment, the prod and non-prod environment is same, right? Maybe, may not be. It all depends upon the cost and then ROI, because if your production, see, one is, if the cloud, yes, it is easy to get a quickly, it is easy to get the production size environment, so that you can get both prod and non-prod as an equal size. Maybe in data center, they will not allow you to procure as many as machines for your performance environment. With the cloud, it is going to allow us to get this additional flexibility. Uh, but it is not going to be always the case. I mean, again, it all depends upon your ask. You need to ask it, they need to provide it, you need to justify it, and they have to get convinced. But with the power of cloud, yes, you will have that flexibility. Next question is on the stubbing, right? Yes, to test your component, the downstream services not required, right? Because you're going to test only the component, your application component. It might be speaking to a mainframe. You're not going to test the mainframe. In which case, mainframe can be replaced with a stub, right? So what you need to take care of is your stub server should be similar to your mainframe when it comes to response time. It should not be super fast. It cannot just respond with 1 milliseconds or 2 milliseconds, because depending upon the time that your application is going to take in terms of connecting to your mainframe, your thread utilization in your application server is going to change, right? If it's going to wait for 5 seconds, your thread is going to be waiting. It is not going to be idle, or it is not going to take other connection, right? So which means you need to simulate a different same kind of a latency with your stubbing also. If your mainframe is going to respond between 5 to 8 seconds, you have to make sure your stub is going to respond within 5 to 8 seconds. It should not be 5 milliseconds or 10 milliseconds. That is something you should take care of when it comes to stubbing. Otherwise, stubbing has to be mandatory, because you cannot just have all your third-party servers, your payment gateways, your mainframe servers, all these things has to be stubbed for your efficient, controlled performance testing. Okay. If anyone asks any other questions, or I would say, if any of you might be experienced people in any of these areas, if you also have any other opinions on these things, feel free to share it, so that it also be useful to me and useful to others as well. So if anyone have any other questions, any other opinions, feel free to share it. There is one question: how efficient? Sorry, Subbu, I'm not very. Um, I'll get back to you. Probably you can tell me what is that you mean by EBPF tracing. I'm not aware of it. Okay, so yeah, anyone has any other opinions, comments? Feel free to share it.
Satish, one question. Even though if the app servers are in cloud, right? So they say east bay. So if it is cloud, still we are doing east side and west side testing. I don't understand if it is in cloud, why, if it is a data center, we understand, okay, if it is in west zone, the east people will be, the response time will be high, correct? But
Correct.
even though if it is in cloud, again, they are saying east side servers and west side server. Will it be like that or?
See, it is depending upon whether it is going to be private cloud or public cloud. Your cloud vendor, where is he going to provision it, and who is it going to be end user? Say, for example, if your end users are going to be spread across your US, they are going to be from every location within US. Then, ideally, you should have your application server hosted in different zones, in the east, in the west, in the south, in north. We call it as a CDNs also, right? Content delivery network. Your CDN should be there in one in Florida, one in Seattle, one in California, one in New York, so that people who are getting connected from Florida, they will not go to Seattle. They will get all their static content at least from the nearby Atlanta or nearby Florida region. People from New York should get it from Chicago. People in Seattle should get it from California. So their CDNs has to be available in the nearby zone, which means when you're going to do a testing, right, you should have your load generators across these different regions. That is number one, so that you will mimic your actual end user scenario. You will have 100 users load generators, 100 users, 100 virtual users from one load gen from Florida, one load gen from uh, one load generator from south, one load generator from west, and then you have to have your cloud environment similar to production, right? Which is nothing but similar to production means they might have CDNs in some places or all the places. They might have application servers in one zone or multiple zones. We don't know, right? They will not probably will not even reveal it. We will ask the cloud vendor to provide the environment similar to in production, or our own infra team to provide an environment similar to production. And then while we test it, we will evaluate the response time from each of these load generators to know what is the user response time from each of these load generator. So if at all we know where are these, if it is going to be a private cloud, right, we know it might be there in US West or US East, and then we will have load generators across the US location depending upon your end user location, and then do the you need to test it and understand whether the response time is going to be same across region or it is not same.
Okay.
Yeah.
Satish, Arun from this side.
Yeah, please.
Satish, just see what are the things you have described regarding your resiliency. Could you make any type of difference between failover and resiliency?
A little bit. See, again, these are all the terminologies, right? Earlier, we used to call it as a disaster recovery, failover. Now the terminology is resiliency. Okay. So disaster recovery is again when a disaster happens, right? When a disaster means it could be a network outage, it could be a one server coming down. What happens? That is what we used to call it as a disaster recovery. And failover is again similar thing. When something failure happens, what happens? But now the new terminology is resiliency, where they have included a lot of chaos condition. Just not about server coming down. It will include your say disk space usage, your network latency, network outages, sudden increase in spike CPU, your hard disk getting crashed. So a lot of chaos condition, including it, they call it as a resiliency, which means your failover is a subset of resiliency. But again, all these things are purely driven by your organization. There is no specific industry definition for these things. People like Netflix, Microsoft, they have coined these words and people start using it. But as you said, everything can be done using failure testing itself, right? But now they call it as a resiliency.
Okay, Satish, thank you. And so this just only 1 to 2 words means what are the things we have done just before your performance testing, and now everybody are telling about cloud. Just give me 1 to 2 differences between these two, so that it will be much more clear for me.
Sorry, I couldn't able to follow it. Can you repeat that again one more time?
Okay, you just see just before what are the things we are just doing about the environment physically, but now everybody are telling about the cloud performance testing and something like that, right? Just in 1 to 2 sentence difference, just make it to be differentiate between the two.
See, when it comes to environment, right? So one major difference is setting up your load generators, setting up your performance environment earlier need lot of forecasting, lot of prior investments, proper decision making has to be done for any project. For a greenfield implementation, say if it is going to happen in June, right? Now, if development is starting now, your architects or a performance engineer has to spend a lot of time understanding what is the requirement in terms of environment, how many load generators you need, how many database servers you need, how many application servers you need, and then you should go and place that request and then get approved, and then you should go and use it after the procurement. After 3 months, if the requirement gets changed, if the user pattern is going to change, if they're going to expect a lot of load, then again you may need to go and request more load generators. With cloud, that is going to change. You don't need to worry about it, right? Because cloud provides you demand on the infra on demand, so you're not going to overspend with the infra cost, right? Yeah, whatever you need, you will get it. If in case you need more, you will get it, and you will pay it only for that time period. And if you once you don't need it, if once you go to terminate those missions, you're not going to pay anything to the cloud vendors. So that is going to be change. That is going to be one big change when it comes to environment with what we have been doing earlier with the data center based environment. Now with the cloud. Second, in terms of your testing and engineering, I think I talked about it earlier. It is not going to change a lot. Only few additional scenarios we are going to bring in. Otherwise, our regular load, stress, endurance, heap analysis, thread dump analysis, JVM analysis, garbage collection, everything is going to be same.
Okay, Satish, thank you so much. Means you are just trying to access according to the environment, that is need to be changes something. Otherwise, everything is same, right?
Yeah, I would say pretty much same. That's correct.
Yes, Satish. Thank you so much. Thank you.
Satish, one question.
Yeah, please go ahead.
Something that is called a CI/CD, right? Can you talk a little more about it? CI/CD?
Nothing but your DevOps, right? Continuous integration, continuous testing. So your developer deploying a code, developing a code, and then you'll be deploying the changes. And then similarly, every developer will do their own code changes. And then once your code is checked in, then you're going to get a war built and deployed, right? That is going to be part of your continuous integration and continuous deployment. So things gets integrated continuously. You 5 developers develop their own code. They will check in their code to say GitHub, and in the end of the day, in the evening, things get integrated automatically, and then a war file is getting generated, and then it will get deployed. And then CT is continuous testing. CI, CD, CT. Continuous testing is once the code is deployed, you have a functional automation, you have performance testing, right? So that is what we talked about in the DevOps world, how it is going to change, what we are going to do in DevOps world, what we are going to do it in sprint based testing, what is going to happen, what kind of engineering things are going to happen within the sprint, and then a partial workload of automated performance regression will happen in a pipeline, and then before it goes to production, we'll do a complete performance testing. So CI CD is continuous integration from a development perspective, CD is deployment, continuous deployment, and then CT is continuous testing.
Okay, how it actually affects our performance testing activity?
So that is what I explained how it is going to impact, right? It is not going to actually, it is going to affect. It is going to change the way we are going to approach our performance testing. Um, the codes are going to get continuously developed, right? Which means continuous deployment is going to happen. Once it code is deployed, automatically performance testing has to be executed. For that, we have to have a regression suite for say your microservices or APIs or landing pages. For that, we will have a script which is not going to get impacted, that will run automatically every build. And then for the code that is getting developed within the sprint, we will be part of the team where we'll work with the developer to do the code profiling, the engineering work, all these things. And after the end of the sprint, our regular load testing, stress testing, endurance testing will happen as part of your production deployment. So those are three things. One, for every deployment, there will be automated performance testing for a limited scripts, limited workload. Within sprint, engineering is going to be there. And end of the release, we are going to have a complete performance execution, similar to what we used to have it earlier also.
Okay, so this DevOps and Agile only, they are calling it as CI/CD testing, is it?
Yeah, it's all people use different words and different things, right? Uh, um, DevOps is more of the way you're going to do your testing and engineering. The teams gel together to deliver the product in a very faster, efficient way. Within that DevOps, continuous integration is going to be there, continuous deployment is going to be there, continuous testing is going to be there.
Okay.
So somebody is
Okay,
going to
thank
ask you CI/CD.
you.
Do you have done CI/CD? If the question is
Mm.
nothing but, have you involved in doing the performance testing in DevOps, in Jenkins, in the pipeline?
Okay, why Jenkins is coming in CI/CD? It is actually all together there. When they are talking about CI/CD, Jenkins is also coming. So,
It's
is
one
it
of
a
the
small plugin?
Jenkins is a tool to do this. Jenkins is nothing but a batch scheduler, I would say. You need to do there has to be 5-6 jobs, right? One is going to be a deployment, which is nothing but a war file will be deployed automatically. One job will take care of that. Once that is done, a smoke test has to be done, and then automation test has to be done, and then performance testing has to be done. So Jenkins is a tool which will take care of this automatic scheduling of your batch jobs. It's
Okay.
to keep it very simple. To answer your question, to keep it simple, this is how Jenkins is going to come into picture. You can
Okay.
assume that Jenkins is going to be a batch scheduler.
Scheduler. Okay.
Satish Velan here.
Hi.
In the new advancements like HTTP2, like where it's handle all the requests over one connection, and in the fastest user connections like 4G and 5G connections, and the new advancement in GC algorithms like where it can have keep size of 1 TB and past times of 5 millisecond, and in this cloud elasticity and auto scaling, like as apart from leaks like code profiling and code automation, how we see the need of performance going ahead.
Okay, so you touched so many things, right? It all depends upon for your application, for that particular application, what are things involved, right? Yeah, there are going to be new GC algorithm which is going to do the optimization by itself with the your G1GC or other algorithm, the minimal pass times. But if the code is going to be bad, it is going to be bad, right? The performance is still going to be bad. Whatever your GC algorithm is going to be, whatever your replays are going to be, which means your
Yeah,
engineering is
but
still
the
going to be
thing
relevant.
like yeah, like the thing like starting from connections, here the connections starting from connections part, and there is memory issues, and these are getting like kind of like the importance is getting like minimized. Like we use as part of like these connections and memory we used to monitor or monitor. This is getting like that new advancement is getting like the importance is getting minimized. So my point is
No, I
like,
don't think I don't think importance is going to get minimized. You say the 5G or 4G network speed is going to be fast. And yes, the network speed is going to be fast. Your latency is going to come down, which means earlier, if it is going to take 250 milliseconds of a latency, now it is going to be 10 milliseconds or 20 milliseconds. But if your application server side code is still going to take time, it is still going to take time, right? The 5G is not going to have any impact on the bad server side behavior. And similarly, your GC algorithm, similarly, whatever heap you're going to have it, right? Be it as a 10 GB or 50 GB or whatever GB, still there's going to be memory leak. Still, you're going to spend too much of money on the resources. Yes, there are going to be with the new hardware, performance is going to be super fast. Even the impact of see, if earlier if your method is going to take 2 seconds, right? Now with the very efficient hardwares and disk, it is going to come down to, even with the bad coding, it might come down to 500 milliseconds. But yeah, those things are going to, the bugs might come down, the impact might come down, but I don't see it is going to largely impact the role of tester or engineer drastically, at least for a couple of years.
Okay.
Yeah, there are going to be advancement. There are going to be advancement in the infra, the way the JVM itself is going to handle a lot of performance problem that is going to come, but it boils down to the developer who is going to do the coding.
Next 5 years. Yeah, when we look for like performance, like a career for next 5 years, like as we knew, apart from these code related issues, like most of the things is getting handled by this new advancement, like as you said, like with starting with connections, the number of connections, the browser spans,
Correct.
the latency part of user speeds, and the memory issues, like with the new GCs, where it happens. Earlier it was like in 32 bit environment, so it was like 1.5 GB. Now it is getting extended where with 64-bit, and the new advanced where the heap is like can go expand about 1 TB, where the past time is like 500 milliseconds, where the memory problem will happen.
You can go and ask for 1 TB RAM. That's not a problem, but you're going to spend money. Do you really need as much memory? Yes, cloud is going to provide you big missions, memory optimized missions, but you're going to spend too much of cost as well to these people, right? Do you really need this many memory for your application? And the one above your application, right? You about the infra, about the connections. Yes, all these things are getting optimized by the by your browsers or by your server, Tomcat or JBoss. Those products, they come up with a lot of optimization. But underlying is still going to be your application code. It is going to be developed by the 1 experienced people, 2 year experienced people, and that is not going to be super efficient at all, right? Obviously, there are going to be performance bottleneck at the application level, your database query level, which is still requires your testing, a lot of engineering, a lot of profiling. Certain things will be taken care. See, even if the GC algorithms are going to get advanced, if your application is going to have memory leak, it's not going to have any impact. GC algorithm is not going to remove the memory leak. It might try to probably if crash. Correct. It will postpone your problem. It might not crash within 3 hours. It might go and crash after 6 hours. That is what it is going to do. It with 1 TB RAM, or 20 GB, 30 GB heap, you will get it from the cloud. But you're going to spend too much of amount again to your cloud.
Got it. Like,
yeah.
Thanks, Satish.
Okay, guys. Super. Fine. I think we are on time. Thanks a lot. Thanks a lot for your time and your questions. And have a nice New Year. All the best. Thank you.
Same to you, Satish. Thank you so much.
Yeah. Thank you. Yeah. I will share you the contact and in the WhatsApp group. Thank you.
Thank you, Satish. Thank you,
Satish, are you there?
Yeah. Yes.
Yeah, just one last question. Satish, regarding the programming languages, if you want to suggest to a performance tester, do you think we should focus more on Java or Python or any other language?
I would still say Java. Okay.
Okay.
From a performance testing perspective, wanted to be a performance engineer, I would say to start with Java. Um, because over last 5 years, 10 years, 20 years, we have seen how Java has evolved. Yes, Python, JavaScript is overtaken Java a bit, but their use cases are a little different. The use cases of machine learning, analytics, where Python is overtaken Java. But from a web application perspective, still um, we see the backends are developed using Spring Boot, and even microservices also is developed in Java. So from my perspective, I would say if you want to pick it up a programming language, it's going to be Java. But when it's going to be part of, if you want to do a lot of automations, right, for a DevOps automation, if you wanted to be part of the automation process, then I would say Python or JavaScript would be a good choice. Yeah, more from engineering perspective, I would say Java.
Yeah. Okay. Okay. But
More from
like
automation
how the
perspective,
trend is
Python.
changing.
Right?
Yeah, the way trend is changing, and you suggested that one should be a full stack tester.
Correct, correct. Yeah, yeah.
From that perspective, do you think Python is taking over Java?
No. See, there are two things, right? One, full stack tester is where you should try to understand, where you should be try to learn the automation tools like Selenium, right? There, if you see, Java is still very, very important. Java or JavaScript is still important because most of your automation tools are supports Java and JavaScript. So from that perspective, Java is going to be important. If you wanted to be SDET, where you need to know development, there probably depending upon your project, your enterprise, then you can choose whatever you want. But still, Java is relevant there. I would prefer Java. But in terms of your automation, when I say automation, if you wanted to do the some process automation in DevOps, you need to probably do a lot of automation in terms of result analysis. Um, in that cases, your process automation, when it comes to that, I think Python is something is going to be helping us in achieving that. So it all depends upon what you want to do. A lot of automations, creating small utilities. Python is going to be easy. It is going to be important to learn Python. But otherwise, performance engineering or automation tools, all these spaces, Java is going to be still relevant.
Okay. Okay. Okay, Satish. Thank you. I won't take much time.
Yeah. Thank
All
you.
right. Thanks.
Yeah.
Hi,
Thanks a lot,
Sadish.
guys.
Sadish, one more question.
Oh, yeah. Okay, sure.
Now we have this application systems also changing, right? Not just for the cloud or DevOps anything. Like now the new things we're adding, like microservices and other things, Dockers and other things, right? So what are the current trends? Can you explain? Right? Because we need to learn, understand about those things also, right? Application components also.
I didn't get the question clearly.
Like earlier, we used to have just a web server, application server, and database. And database can be either Oracle or SQL database, and application server as something JBoss or something, right?
Okay. See, I got it. See, I would not say that is a trend, right? That is more about your application architecture. You can have, see, Java messaging service, or it could be an MQ. Now it is Kafka. You might have a lot of streaming services. You might have mainframe earlier. Now you might have your other analytical engines, Elasticsearch, Oracle, MongoDB, right? Different components, different softwares, different technology, different tools, right? People now have a lot of options. They no need to stick on to Oracle. They can choose whatever DB they want. They need to just stick on to JMS. They have Kafka or other streaming services. So which means it is not a trend, I would say. It is more about you shouldn't try to, we are not going to master any of these components. We cannot go and master Elasticsearch or MongoDB. One thing is important is wherever you want to do a testing or engineering, you should understand your application architecture. What all components are there in your architecture? Have a clear picture of those diagram, software component diagram, and then for each of this layer, you know how the interaction is going to happen from starting to end, and each of these component, how are we going to measure the performance? How are we going to monitor the performance? What are the tools available to monitor the Elasticsearch or Mongo or Kafka? So we should have a proper monitoring strategy. And then if it's required to do a component level testing, you can do a component level testing on Kafka or component level testing on Elasticsearch. So we can do a component level testing, individually testing those components. From an end-to-end testing, we should clearly know how the data flows, and we should have a proper monitoring strategy so that it is not going to be a black box. When we say 10-second response time or degradation response time, we should be able to go and say, yes, this component of Kafka is having high CPU or memory, or probably there is a Elasticsearch where the response time is taking more for this query. So that is how we should look into from an application architecture perspective. I don't know whether it is not a trend. It is going to be part of understanding your application architecture. Accordingly, have your monitoring strategy, and accordingly do your analysis.
So basically, it's replacing that existing whatever architecture or anything. Existing components is replacing.
Now it could be 10-12 components. So which means the complexity is going to be more, but we should keep it very simple. Understand, very important thing is you should have a clear picture at front of you. What are the various components, how the data is going to flow from back and forth, and then for each component, how are you going to monitor, what tool you're going to monitor, and you should be able to use those tools while you do the execution. That is going to be as simple as that.
So for the database, if you are looking into the earlier, we tried to learn about that particular Oracle.
See, earlier for Oracle, you will look into AWS reports.
Yes.
Now with say, if it's going to be Elasticsearch or MongoDB, each of these tool will have its own monitoring component, monitoring tool. It will provide you the query response times, query performance. So you cannot go and master it. Today Elasticsearch is there, tomorrow it might not be even there. It is evolving like anything. So once you know the application architecture, once you know they are using ABCD database, then go and check within the database what are the monitoring tools available, and accordingly you get the access and then start using it. It's not like Oracle as an AWS report where we do a lot of analysis. There is no other standout database now in the market where we can go and learn. It is evolving, it is changing, dynamic in nature. So there is no need to go and master any of these other database apart from Oracle AWS analysis. We haven't reached that stage where you can say, yes, similar to Oracle AWS analysis, you can also go and learn this thing. That is not something we are seeing today as of today.
Okay, yeah. Thanks, Satish. Good to know that all this information from you. Yeah. Thanks.
Okay, guys. Super. Thanks a lot. And if you have any more questions, you can just post that question in the WhatsApp group. Okay. And thanks a lot. Thanks a lot for your time.